So in this problem, we're given two sticks. We're told that stick number 1 has mass m, length d, and angular velocity omega 1, and that it's rotating about its center, which gives it a moment of inertia of 1 over 12 md squared. Stick number 2 has exactly the same dimensions. It has mass m, length d. We don't know what its angular velocity is, but we know that it's rotating about its endpoint, which gives it a moment of inertia of 1 over 3 md squared. Now for part A, we're told that the kinetic energy of the rotational kinetic energy of stick number 1 is equal to the rotational kinetic energy of stick number 2, and we're asked to find the angular momentum of stick number 2. Now throughout this problem, for both parts A and B, I'm going to be using a slightly non-standard formula for angular momentum. It's something that you should know and something that you should keep in mind, but it's not the normal. So the normal formula is 1 over 2 I omega squared. You can modify that a little bit by noting that angular momentum L is equal to I times omega. So you can use a slightly different formula, which is L squared over I for K. And so that's going to be slightly more convenient to use for this problem, so I'm just going to write it up there so that you can remember it. So we're going to plug that into this formula right here. We get 1 over 2 L1 squared over I1 is equal to 1 over 2 L2 squared over I2. And so then it's a fairly simple thing to just rearrange the formula. We get L2 squared, isolating that, is equal to I2 over I1 times L1 squared. I2 over I1 is just a factor of 4. So we get 4 times L1 squared. Taking the square root of this, we get L2 is equal to 2 times L1. L1 is just I times omega, which is 1 over 12 md squared omega 1. So we get 1 over 6 md squared omega 1 for the angular momentum of stick number 2. Now in part B, we're told that the angular momentums are the same this time. So L1 equals L2. And we're going to use exactly the same formula, because what we're asked is what is the kinetic energy of the second stick this time. So now the kinetic energy of stick number 2, K2, is equal to 1 over 2 L2 squared over I2. So then we can plug in L1, and we know that I2 is equal to 4 times I1, so we can plug that in as well. So we get 1 over 2 L1 squared over 4 I1. And so now we can pull out the 1 over 4 term and plug back into the regular rotational kinetic energy formula. So we get 1 over 8 times I1 omega 1 squared. We know that I1 is still 1 over 12 md squared. So we get that the kinetic energy of stick number 2 is 1 over 96 times m d squared omega 1 squared. So these are our two final answers. Given that the two sticks have the same kinetic energy, the angular momentum of the second stick will be 1 over 6 md squared times omega 1. Given that the two sticks have the same kinetic energy, the same angular momentum, the kinetic energy of the second stick will be 1 over 96 times md squared omega 1 squared.